Work done in irreversible process. Irreversible process, what is irreversible process? The process which continues in one direction and it is fast. Fast and in one direction only. Means reverse direction is not possible. So that's why written irreversible. It will be fast. So suppose you have a piston. You have a piston and there is gas inside and you compress it. When you compress it, the piston will come here. It will move here. Okay. So you are pressing it in one direction. You are not moving in the opposite direction and you are doing it very fast. So at any point of time, you certainly know in which direction it is moving. It is so fast that you know the direction. So this type of system will be known as irreversible system, and the process is termed as irreversible process. So as I gave you the example, if I apply external pressure Px, okay, and it moves towards left and it is very fast, then obviously I will say it is irreversible process, because at any point of time I know in which direction it is moving. The work done in this case, okay, in case of irreversible process, the work done is given by minus P external delta V. This minus sign is just taken to comply with the sign convention. Okay, if we don't have this minus sign, then our sign convention that the work done on the system is positive and work done by the system will be negative will fail. So that's why this negative sign is there. So if the question is why this negative sign is there, your answer will be simple: to comply with the sign convention that work done on the system is positive, work done by the system is negative. Then work done in reversible process. Reversible process are slow processes. So if a process is happening very slowly, very slow, okay, so much slow that at any point of time you can't say whether it is moving in right direction or in left direction. So suppose you are applying pressure. I consider the same example, okay? You are applying the pressure on the piston, but you are applying pressure so slowly that at any point of time the piston looks it is stable or stationary. Okay? At that point of time, P external will be actually equal to P internal, approximately P internal. I am writing just approximately, but if it is ideal reversible process, we will say these are actually equal at any point of time. The reaction or the process is very slow. So when the direction of the process can be changed by slight change in pressure in this case. So suppose you apply delta P pressure in this direction, which is infinitesimally small. Okay, so because it is infinitesimally small, instead of writing delta P, usually we write it like delta P, lowercase delta P, to show that it is actually continuous process. If you have done integration and differentiation, you should know this, okay? Or if not done, you will do it in math. So in this case, at any point of time, you don't know in which direction the reaction is moving, and the direction can be changed by slight change in the conditions. In this case, slight change in pressure, then it is known as reversible process. So a reversible process proceeds infinitely slowly by a series of equilibrium states. Equilibrium states means stationary states. P external is equal to P internal, equilibrium, such that system and surroundings are always in near equilibrium with each other. In a reversible system, at any point of time, the internal pressure is almost equal to the external pressure. This is we have talked about. The formula which you need to remember, and you will be using it in numericals, W reversible is given by minus integration over Vi to V final, V initial to V final, P external dV. Now you don't need to use this formula like this, okay? We will simplify this formula so that the usable form you remember. But you should remember this one also, because the questions are asked directly based on this form of formula also. Although not calculations, but this form of formula. So here, because P external is equal to P internal, we can write it as P internal also. So both formulas are correct because it is reversible process. P external and P internal will be equal. Now for a pressure P, volume V, for n moles at temperature T, this is the ideal gas equation. For an ideal gas, this is the equation. If you multiply its pressure and volume, it will be equal to its number of moles, gas constant and temperature. Gas constant R is 8.314 joule per Kelvin per mole, or if you represent it into ATM liter, then it will be 0.0821 ATM liter per Kelvin per mole. If you represent it in bar liter, then it will be 0.0831 bar liter per Kelvin per mole. So therefore, we can get from here, we can get the value of pressure, because if you remember in previous question, we have pressure but dV. So obviously we can't do calculations if one is pressure, the other one is volume. So we have to convert this pressure in terms of volume, and we can convert this pressure in terms of volume by this equation. Okay, so pressure from here can be equal to nRT by V. So if we write this is pressure equals to nRT by V, and we substitute it into this equation, we will get this value. So if you have not done integration, you will not be able to understand how we have done it, but you have to remember this formula, that W reversible will be equal to minus 2.303 nRT log V final divided by V initial. This is ln, log base E. Log base E we have converted into log base 10, and when we convert log base E, that is ln is also written as log base E, it will be 2.303 times log at base 10. So that's why this 2.303 is there. You have to remember this formula, important one. Then free expansion and isothermal process I will consider in next class.